We're going to talk today about React Native in Microsoft Word for desktop. So let's get on with it. I'm Nikolai Aristo. I'm a senior software engineer at Microsoft. I'm going to be presenting with Shiven. We work on a team for Microsoft 365, which is also known as Office mostly. And we're building foundational code, shared code for Word, Excel, PowerPoint. What are we're going to cover? So some of you may know our apps, we ship them for our customers everywhere. So we've got web apps, we've got iOS, we've got Android. But we also have Windows, and we've got macOS desktop. And in this presentation, I'm going to concentrate on the desktop portion. And we're going to showcase specifically how React Native framework helped us bring a feature from a Word web application onto the Word desktop. And then Shiven will demonstrate how you can take advantage of React Native for desktop for your customers. Now, I just want to take a step back. So many of you are familiar with mobile development, web development. And I just want to go over why would a company consider a desktop application with React Native. And there are actually many good reasons. So first of all, existing users. So many of you in the audience, I see you are already using desktop like laptops, Apple. I mean, this I'm presenting on one. So there is like a ton of users who are already using desktop operating systems. Performance. So you can, React Native is very flexible, and it allows you to go down to lower levels. So you can really tweak your applications like as much as you want. You've got larger screens, and you've also got multi-screen support. So those things are much easier, on a desktop application. Then you have, if there's any new OS capabilities that are coming out, you can take advantage of them right away because you can just go way down and use the newly APIs. You don't have to wait until the web ecosystem picks it up. And there are existing desktop apps if you're working on some, and you can insert React Native into them and make them shine, make them modern. And finally, one of the cool things about just React Native ecosystem is that you can do a lot of code sharing between the web, the mobile, and the desktop. So especially application logic code you can share. So going back to our specific feature that we reported. So it was like about late 2022. That's when the generative AI revolution happened. And at Microsoft, we have a feature called Copilot that does generative AI. And the Word web application had a head start, and they've integrated the Copilot pretty fast. And our team's responsibility was to bring this Copilot generative AI feature into our apps, Windows and Mac, where we have like millions of users. And of course, with such things, the timeline was yesterday. Like, we need this feature. But then, again, we have a reality check. So Word has a large code base, millions of lines of code. Like it includes a large portion of C++, very intricate C++ code. And some of this code is 30+ years old, probably older than some of you in this audience. But it still works. It works. And we have, of course, large user base, both at home users and enterprise users. So what that means is that our feature needs to be created, rolled out in a safe manner. It cannot degrade existing experience, so it has to be an add-on. It has to improve the user experience. It can't crash, it can't hang. So these are like the requirements. And of course, the timeline for this feature is yesterday. And React Native comes to help here as a superhero. So basically, we worked with React Native for quite some time now, both in Windows team, in Xbox team, Office team. And for having React Native has many benefits. So first of all, we've got fast inner dev loop. So we've got things like fast refresh. They work. I mentioned code sharing. So that is a huge thing. It can really improve the speed of the rollout of how feature can be implemented. We've got native look and feel. That's a huge one. So basically for customers, they don't care about what tech it is. They just want to make sure that the app looks as it's supposed to look on whatever device they're using. And with React Native, we've got near native performance. So there's no lag or anything. So it's pretty optimized. Going more. So with React Native, you can easily interrupt with existing C++ and C# code through either native modules and turbo modules, and Shiven will show you how to do that. It's already being used in many Microsoft critical apps, so it's very stable. It's a stable platform. Yeah, it's used in Xbox, it's used in Windows, and we've been investing in it for over like 7+ years, so it's good. So React Native is one of the recommended platforms for building Windows applications. So that's a huge one. And of course, it's open source. So like you can take part of it. You can send pull requests. You can set the direction of this development. We're all like really open. So now let's go where we started. So I'm going to launch a Word web application to show you the feature itself. So let's navigate to it. It's just whenever you open the document, a new document, you're going to see the Copilot box. So it's a rich text box that you can use. You can add some references, and then once you press submit, it'll go to the server to generate a story in your Word document. So this is a Word application. That's what we're working with. So we've got some things here. We got the theming. We've got the text box. People have mentioned text box. It's a rich text box, so you can actually reference like other files. You can reference people in it. And we want to bring this experience to the desktop application. But what we didn't want to do is we didn't want to basically copy and paste it pixel for pixel. We wanted to share code as much as possible, but at the same time, we wanted to make sure that we deliver a feature that looks and feels great for desktop users and what they're used to. And let's take a look of how it looks. Again, I'm starting now the Word native application on Windows. And here I'm going to bring a Copilot. And here I've got the Copilot experience as it's implemented for Windows. As you notice, we've actually, instead of just having a box, a text box, this is like a native window. You can move it around, so it provides you like a very flexible experience. You can put this window on a separate screen if you need to, so it doesn't get into your way. Again, we've got the theming, we've got the hover effects. So users can just like use it, and it looks like it just is like a regular Windows component. But not only that, not only we implemented it for Windows, we've also have this experience on macOS. And here I'm going to launch a Mac version of Word again, and I'm going to bring the Copilot feature. And here's how it looks on Mac. As you see, you've got the rounded corners. You've got again, the text box that looks native for Mac. You've got the buttons. You've got the references, theming. So accessibility, I didn't mention it, but accessibility is a huge thing for desktop. And this is how it looks, the finished product. And React Native made this possible. And how can you take advantage of React Native? And this is something that Shiven's gonna talk about.
Thanks, Nikolai. Hey everyone, I'm Shiven and I'm software engineer 2 at Microsoft, where I'm part of the React Native platform team. And I also work on Copilot for Office. It's my second time at Chain React. I was here last year and it's great to be back. And after the events of the last 12 hours, it's great to be doing a Microsoft talk. Tough act to follow. So as you know by now, we've been heavily invested in React Native for desktop, and we continually seek ways to bring shared experiences on web and mobile over to desktop, including Copilot. And Copilot's not the only experience we have. All these apps that you see are either fully written in or host experiences written in React Native, and they run on multiple platforms, including desktop. But how can you do the same? How can you get started with React Native on desktop? So let's talk about how you can bring your React Native mobile application to desktop by way of a short demo. So we're going to start with a sample blank React Native application. As you see, it's completely blank. It doesn't have any code. And let's create something basic. Let's make this app display your device's battery level. And we are going to make the app display the battery level, and we're going to bring it over to desktop. So first thing that we're going to do is we're going to add the desktop platform to the project that we have. So you can open the terminal and you can just add Windows by running npx React Native Windows init. And you can add macOS as a platform by running npx React Native macOS init. For the purposes of this demo, let's add Windows as a target. We will make the app for mobile and bring it over to Windows. I've already run React Native Windows init command. So if you go to your project, it will actually create a Windows target folder that is similar to your Android and iOS folders. There it is. And this just has mostly native Windows code that is required to render the application in Windows. So now let's make our app. So first, we need to store the battery level somewhere. So we'll add a battery level state to store the battery level. So there it is. And we will add the state here. And after this, we're just going to add a very basic UI, which for the purposes of this demo, I made. So here's the state, and we're just going to paste the UI. There it is. And if you see what the UI has, this just is like a container view, and all it has is like a header that says battery level. Then it has like a view which has like a bar that shows the battery level, and then there's just a text that shows the battery percentage. And so we can run this and see what we have. So to run on Windows, you can basically open your terminal and you can run npx React Native run Windows. And it starts up a Metro server, or it will reuse the Metro server instance if you already have one running. React Native Windows supports fast refresh, like Nikolai said. And so I already have the Metro server running right now, as you can see. So let's see what we have. So this is our Android app, and this is our Windows app. So of course, the value is null because we haven't set the battery level yet. However, the battery APIs are different on Android and Windows, right? So for this, we would need to write a turbo module to actually access the local battery APIs on Windows and Android. So for this demo, I have already have a basic turbo module that we can use. Let's check it out. So first, we have our module spec in TypeScript. It has the get battery level function that returns a promise with the battery level as a number. Our module name is battery manager module, and this spec is what your JavaScript code calls. And essentially, we need to implement get battery level function in native code. Now you can go to your package.json, and there's a CodeGen config key over here. And I've added Android as a target with the package name. And this is for CodeGen to pick up. We will write our Android turbo module in Kotlin. And CodeGen essentially creates like the interop layer so that our JavaScript spec can actually call into the native implementation of the battery manager module. So now we can go to the actual turbo module implementation for Android. And here it is. So this is a Kotlin class And here is the native implementation that we have of the get battery level function. It uses Android Battery Manager API to get the battery level. It resolves the promise with that, or it rejects it if there is an error. And finally, we need to register the module in the package. So here is the battery package. This is where I register, and this ensures that our module native implementation is packaged in the app. So to set up a basic turbo module, you need to write the typescript spec, implement the module, register it in a package, and then add the target in package.json. So these are the main steps. Now, to use the module, I am just going to go back to my app.tsx, and I'm going to call into the get battery level function. So I'm going to import the battery manager module that from our spec, and we're just going to call the function after this. So we imported this here, and we will now call the function. And for now, we're just calling this as a use effect. And all this is doing is it's just calling the awaiting the get battery level function, setting the value, and for now we'll just run this like every 5 seconds. And let's see what we have now. So if you open your Android emulator, it does show 100% battery because this is an emulator. But you can go to your emulator and change the battery level, as I will do now. And this should just update 25%, and it does. But now what about Windows? We would need to have that turbo module also work on Windows, right? So let's get that going. So to get the module working on Windows, the steps are actually the same. First, we go to our package.json, and we add the Windows target for code gen. You just write the Windows key here, and you can write Windows native modules in C++ or C#. For this demo, we will use C++, and that's the namespace that our C++ module is going to use. And let's check our spec. So React Native Windows is able to reuse the same spec we created for Android. We don't have to rewrite this for Windows. So this means one less step for us. So all we need to do is implement the battery level function for Windows, which I have done here for this demo. So what we do here is we will first import this CodeGen spec that CodeGen produced for us. And the name of the file basically starts with native, it ends with spec, and it has a module name in the middle. This is similar to the Android file naming convention. And CodeGen is just taking our types of spec, and it's just generating a header file, so we need to just import that. Every turbo module is a struct in C++, like it was a class in Kotlin. You prefix that as a React module with this macro, and this signifies that it's a React turbo module. And then I import basically the generated module spec from CodeGen. I know these are like intricate details, but these are just the required steps for declaring the module. But now we write the actual implementation of the function. That's the most important part. So every function in your spec has to be denoted as a React method. So it's coming from the spec. And you write the function implementation. For Windows, we have the WinRT API. And WinRT API gives us this remaining charge % API. And we just essentially resolve the promise with it. Any future functions that you add to your typescript spec, you just can keep adding it to this module, just prefix it with React method. Finally, we need to package our package the module like we did for Android. We go to this React package provider, and we just import the header over here. And that is all for now. If we go to our app.tsx, because we are reusing the spec, we actually don't need to rewrite this code. So this should just work for Windows. So let's see what we have. That's Android. That's Windows. Windows, it shows 33%. Look at the bottom right, and it does show 33% battery. So thanks, guys. So React Native Windows lets us share the same JavaScript code, the same spec for the native module, the same, you can add the platform with one command, and all of this is also true for React Native macOS. You can write turbo modules for macOS and Objective-C and Swift. It's similar to how you write turbo modules for iOS. You just need to target AppKit instead of UIKit. Finally, native look and feel is very important to us when building a React Native experience, as it is for all of you. You may want to make some platform-specific customizations. You, for example, use platform-specific theming. You want bigger fonts for Windows. It's a larger screen. You may even want your own component for Windows. So Let's make a small change. So we're going to go to our styles file that we have here. And we want the text to be bigger, since it's a larger screen. And we will use a system color for our text rather than hard-coded. So we're going to make this change right here. So React Native Windows works with platform.select API of React Native and platform color. So you can just access the Windows native color. You just have to write the Windows key over here for platform select to have Windows-specific customization. And for macOS, you just write macOS. We're using this color, which is a system accent color. It is like a blue color. And this color is theme sensitive. So my machine is in light mode, but if I turn it to dark mode, the color will become lighter. So that's a good benefit of using platform colors. And I have a bigger font size for Windows. And also I've used platform.select for this style sheet, but you can use it to render your own bespoke components for Windows and Mac. You can just use the Windows key for Windows and the macOS key for Mac. Now, let's see what we got. So this is for Android. This for Windows. It's a bigger text, and it's using a blue accent color. And my device is in light mode, but I can change this to dark mode, and the color will become a lighter shade of blue. If you want to know more about Windows platform colors, we have an app called WinUI Gallery, which you can download from the Microsoft Store. This is the app. And this is the color I used, and I can just essentially change it to dark mode, and this is what it will come. And this is a great resource for you to learn more about platform colors and the Windows design language. And so for React Native components, we have React Native Gallery app, which some of you may have heard of. It shows you all the components that work on React Native for Windows. And both the WinUI Gallery and React Native Gallery are great resources for you. So to make your applications look tailored to the Windows platform and utilize the Windows platform theming. And by the way, this Gallery app is fully made in React Native for Windows. So overall, React Native for Windows can be added to your existing project in one command. It shares your JavaScript code while allowing you to make platform-specific customizations. It shares your turbo module spec. So all you need to do is write the module implementation for your platform, Windows, macOS. You can run your application with one command. All of this is also true for React Native macOS. And like Nikolai said earlier, both the platforms have the things you love about React Native: native look and feel, fast refresh, platform selection, and so on. Also, I'd like to say, most of the stock React Native components will simply work on React Native for Windows and React Native for macOS, so you can just import them directly from the React Native, and they should just work on Windows and macOS. You can learn more about writing turbo modules for desktop on our website, aka.ms React Native. We have detailed documentation over there to get started with creating turbo modules for Windows, as well as sample code. You should check that out. And macOS turbo modules, as I said, similar to iOS, except you're targeting AppKit instead of UIKit. React Native Windows 0.74 is already available. React Native macOS for 174 will be released in the next couple of weeks. And you can also create React Native Windows app on a Mac using parallels, like my colleague Chiara spoke yesterday in her talk. But what about your dependencies? Now, most of you use community modules in your application, right? There are many popular community modules in use today. For example, Reanimated, React Native WebView, and so on. And many of these modules use native APIs as well. So when you're adding a new desktop platform, you do need to check whether your dependencies have support for the desktop platform. How can you find that out? So if your dependency is fully JS, that is, it doesn't use any native code, it should just work with the desktop platforms. But if they do use native code, there are two ways to find out. You can, of course, search in the module code for Windows or macOS folder in the library source code to see if they have the native implementation for those platforms. But also, a lot of popular community modules are on React Native directory, which you can find here. And you can just filter by desktop apps, like you can see, and other platforms to see if your community module has support for those platforms. If your dependency does have support, all you need to do is auto-link your dependency when you add the Windows and macOS platform. And you can auto-link all your dependencies in one command using npx React Native auto-link Windows for Windows or pod install for Mac. Now, we've talked a lot about turbo modules, how you can migrate your native code. But what if you do not want to? What if all you want to test is your JavaScript code? You don't want to touch any of the native bits. And we can do that. For that, we have React Native Test app. React Native Test App, also known as RNTA, is essentially a platform as a package. It provides you test apps for all your desktop and mobile platforms. It's like a thin layer that just consolidates all of the platform level native code for hosting logic for all of those platforms, and it acts like an app of its own as well. What that means is you just deal with the JavaScript, and you don't have to deal with the native code anymore, but you still have full control over the native code if you so choose. RNTA has dependencies to React Native Windows, React Native macOS. So if you want to test your upgrades, you just have to bump the version of any of those dependencies on the package.json, or we have a CLI as well, wherein you can choose from. You can test on newer or older React Native versions. It supports Windows, macOS, Android, and iOS, and it supports the new architecture. You can get started today by just adding React Native Test App to your project and running init test app. You can find more details of this at the Microsoft React Native Test App repo on GitHub. So we built the building blocks in the platforms, so you don't have to. But there are still things to keep in mind when migrating your applications from mobile to desktop, because obviously these platforms are completely different to each other and many things change. So for example, theming is different on desktop compared to mobile. It's even different between Windows and Mac and between Android and iOS, right? We looked at platform colors, for example, and each platform has their own native design language, their own platform colors, and they have subtle UI differences. An example of that is our persona card experience. Persona card essentially shows you your account and organization details, and this experience runs on most of our Office applications like Word, but also Excel, PowerPoint, Outlook, and other Office applications. And this entire experience is built with React Native on all of these platforms. And if you notice, there are some subtle design differences in each platform. So you can see that the link color is blue on mobile and Windows, while on macOS it's green. The corners look slightly different. The buttons are also tailored to the platform they run on. And the experience on desktop is like an on-hover experience. On mobile, it's a full screen experience because it's an app. And so being aware of each platform's specific design language and theming will help in making your apps have native look and feel. And for Windows, you can utilize WinUI Gallery and React Native Gallery to help you in that. Large screen, horizontal layout means thinking about your UI differently. So like in Persona Card, it was a hover experience for desktop, because hover is an experience suited for desktop's larger screen. But desktop also has multi-window compared to the single screen of mobile, so you can render multiple screens. Input types are different when you go to desktop. On mobile, you have touch. On desktop, you have mouse, keyboard, controllers, and so on. Today, we also have laptops with touch screens. So they support all of those input types. And this just means a different mode of interaction compared to how you interact with mobile applications, where it is just touch. So you can take different actions with those input types. And one of those actions is navigation. Your navigation flow is different on desktop. You're doing keyboard navigation with shortcuts. You have mouse click, left and right click, mouse scroll, compared to like a touch-based navigation on mobile. And that can unlock more possibilities for your navigation scenarios. All of this adds to one thing, which is accessibility. Accessibility features on desktop are fully different than on mobile. We have TalkBack on mobile. On desktop, we have screen readers. Different platform colors means you have to think about accessibility coloring. You have to think about high contrast colors and so on. Different input type means focus is different. And that needs to be handled explicitly as well. So even though we give you the building blocks in the platform, these are things you need to keep in mind when you build your applications and bring them over to desktop. A few things that are going to come soon from Microsoft in the next few weeks and months. React Native macOS 0.74, as I said, will be releasing soon. React Native Windows is already on 0.74. You can use it. We are heavily invested in enabling new architecture for desktop. We are working towards Fabric API parity on Windows, and also bringing up our experiences on both platforms to use a new architecture. And you can learn more at our React Native desktop booth. We have it today as well. It's upstairs. And catch us at React Universe later this year, where members of our desktop teams will be talking about some of this work. Now, for the conclusion, I'll pass it back to Nikolai.
Yeah, Thank you, Shiven, for a detailed description. I hope you're not scared to start with desktop, especially with Kira's talk yesterday that you can actually start on your Mac OS. You can launch Parallels and start also creating apps trying for Windows. So we've demonstrated how React Native really helped us develop full-fledged feature, enterprise-grade, with theming, with its accessibility into Word application. So Copilot is a success story. So for you to call for action, if you're developing for mobile web, consider if you have users for desktop for Windows and macOS that could take advantage of the any experiences. We've got a lot of building blocks covered. Shiven has done a great job of iterating through them, but like theming, accessibility, dark mode, light mode, it's all great. Then it's all open source, so you are welcome to take a part in it. We have a booth coming soon, and here's where you can find more resources. So the QR code is, you just go to our website, you can start creating an app for desktop right away. We also have past talks where you can learn more about our efforts. And we've got active blog and Twitter account where we post the latest and greatest, which you can find. And thank you very much. And I can't wait to see what kind of new experiences you guys can create on desktop platforms. Thank you.